In the last exercise, we have tried to do something we call the frame differencing, which we use a background image and use it as a way to compare with the live image in order to make sense of the movement in front of your webcam. So in this particular exercise, we will use another approach. So we call the movement or indication of movement by doing the differencing between, again, the two pieces of image. And in this way, we are not comparing the current image with a pre-recorded background image. We'll try to make sense of the movement by comparing two consecutive images from the video camera. So that means we try to compare the current frame with the previous frames. And if they are different, so it indicates some sort of movement. And by using the difference image, we'll try to make sense the direction, position, and also for example, the size of the object which is moving in front of the camera. So we start with this particular patch first. So we have the video, and then we have a full screen display on top of this particular 800 by 600 pixel frames. So after that, we'll introduce another command which will do something we call the movement tracking. It also belongs to the pixel family. So before we try to connect them all together, we can have a look at the help. And it gives a little bit piece of information. Is we will try to store the movement information into the alpha channel. So in order to achieve this effect, we need to, for example, make sure the pixel video, after it capture each of the frame, and it have to contain the alpha channel. So we can ensure this by using an pix RGBA command. So the pix RGBA is a kind of way to convert the color space into an RGBA format. So it makes sure it has the alpha channel. And the second inlet of the pix movement will be a number, and this number will use, same as before, a form of horizontal slider with the range between 0 and 1 in order to adjust the performance of the tracking of the movement. So this is the live effect. So actually we do not see a lot of difference because we are just seeing the RGB image of this particular whole image from the webcam. So in order to make the appearance of the alpha channel in effect, we'll use another command. Of the alpha. So this is the way to enable the alpha blending of the original RGB image and the alpha channel. So you can have a look of this particular image. So I can change the movement detection by sliding on this particular slider. So if I push it towards the right hand side, you can see that the background a little bit more clear. And once you have the movement, so that means you have two frames would have some sort of difference between the two frames. It will have those changes indicated in the screen as stored in the alpha channel. So the mechanism of this particular slider is depending on the situation. So for example, if your target moves very fast and on top of a very noisy background, you can move it towards the right hand side. It will reduce the signal you can process at this point. But at some point of time, if your target is involved in a more slower movement, you will move it towards the left hand side such that you have more signal to process. So toward the right hand side, you have a less noisy piece of information, and towards the left hand side, you may have some sort of noise which is not created by the movement of your subjects. So the next step we plan to do is actually the same as what we have done in the background subtraction. We try to use the block command in order to make sense of the location and the size of the movement. So again, we go back with this particular pix block command. And the parameters, the second inlet, will actually use the alpha channel. So in the last exercise, we make use of this particular radio button with altogether 5 of them, and the last one will indicate the use of the alpha channel, and the rest will be the X, Y, and size of the block. So if you move in front of the camera, again you see the change in those numbers. So for example, if I move towards the right hand side of the screen, so you can notice the change in this number will be a larger value, 0.8 something or 0.9 something. So if I move towards the left hand side of the screen, you can see the decreasing number of the X value. So of course you can adjust the slider in order to smooth out a little bit of the noise. And same as the last exercise, the next step we plan to do is we try to create an object which move according to the movement of the user. So in this case, we'll make use of two gem head objects. The first one, this particular video, we put it on the bottom of the layer. And the next one, we create another gem head which is on top of the original video. So we use the number 55, which is larger than 50. And again, we have to translate X, Y, Z in order to move the location of the objects. We also make use of a rectangle. Same as the last exercise, we'll do a little bit conversion or calculation in order to convert the value obtained from the pix block, which is a range between 0 and 1, to another value which have the range between minus 5.33 to positive 5.33. By using two objects, one is the multiplication, the second is a minus. So for this one, you can notice from the screen is whenever I move, this particular white rectangle will follow the movement of the objects. And at this point, it's only move in the horizontal direction. And then in the next step, I can also add in the vertical direction. But usually in this form of tracking, a lot of the movement created by the user are usually in the horizontal dimension. So it's quite difficult for a single user. They jump up and down and in order to move in the vertical direction. And if you are using, for example, your body to move up and down, usually you still have a vertical alignment of your body on top of the ground. So it's not very effective to detect only the vertical movement. And you will notice some sort of jerky movement because of the way we implement these tracking methods. So we use the X position directly from the pix block command to control the movement. So in subsequent exercise, we'll try to implement something to smooth out the operation or the movement of this particular block. So again, I try to connect the vertical position, the Y one, on to the translate command and have a look of the difference. If I just do it following the same logic of the X command, we may run into some sort of issue. So we can have a look of the issues. So the first thing is the Y dimension, which indicated by the 600th of this particular window size. And if you use it in the original way, like we implement the square dimension of the window, we have come across another set of figure, which is 8 and 4 instead of 10.66 and 5.33. So this is the first difference. So this is the simple way of connecting them together, and we can have a look of the result first. So it's quite difficult to notice the difference in terms of the Y dimension, and I can try to do it, for example, with my arm only. So it seems that the movement of the rectangle, the square, is moved in the opposite direction of the movement. So it is the misalignment of the direction between the coordinate, which is reflected in the block command, and also the convention we use it in the translate command. So we need to do a little bit of adjustment. So the adjustment is we need to reverse the direction by doing a multiplication of a negative number, and then we place the subtraction by an addition. And then we do the test run again by using the arm movement. So in that case, you can see a little bit more promising result. The movement of the arm and also the movement of the square, they come into the same direction. And then we can further modify this particular result by disconnecting the pix block image to the pix texture, and we connecting the original video image to the pix texture. So in that case, we come with two video streams. One goes through the movement analysis and the pix block, and the other will go directly to the pix texture for the display. And the result will be you have your live image, but at the same time you have the white square. So this is the overall result, or the final result you can try to achieve by using the live image altogether with the, we call it augmented image, which is that particular white square which move along the same direction of your movement. So in this exercise, we have make use of the pix movement command, so which is a way to compare the two images and try to make sense of the direction of the movement. And then we make use of this command in combination of the pix block command we have learned in the last exercise to create a tracking operation. And the results of the tracking operation will go directly to the position of a rectangle or small square. So actually you can replace this small square with whichever graphic you would like to do, and in the end it will become some sort of movement tracking operation which will guide you through, for example, some sort of interaction design where you would like to use the body of the user to control movement of some virtual graphics on the screen. And in the next section, we'll try to make some way to enhance the movement of the graphics. And as I mentioned, at this point it's a little bit jerky, and how we can think of some way to smoothen the operation.